Hello everyone, my name is Uday Kiran. In this presentation for the CMP7001 Advanced Programming Model, today I will be walking you through the system design I created for LMP technologies based on the scenario in the assignment brief. The goal of this project was to design a modern system that replaces LMP technologies' old MS Access based repair management system. This system supports customers, technicians, and administrators, and it handles everything from booking equipment for repair, assigning technicians, logging repairs, and generating bills and sending notification and managing suppliers. My approach was to design entire system using clean object-oriented programming principles on separation of concerns, inheritance, encapsulation, and clear class responsibilities. Let's move to the next slide. In this presentation, first I will start with the introduction, use case models, and the class diagram which I have created, and how the user interacts with the system. Then I will move to class diagrams and explain the structure, and after that I will discuss the polymorphism, design patterns, exception handlings, and designing challenges, oops reflection, and finally the improvements I made for the reassessment. Let's go to the use case diagram. First, this is my use case model which captures the main interaction between three users, that is customer, admin, and the technician. And starting with the customer can book a equipment for a repair. They can receive notification if they on the notification receive button on, and the walk-in customers can upgrade to register, and the and which is the important part of the brief, and the administrator have the most responsible. They can register a new customer, capture the equipment details, allocate jobs to new technician, generate bills, notify the customer, and manage the suppliers, including adding, removing, and flagging non-paying customers as well. Coming to the technicians, technicians view only the jobs assigned specifically to them. They can't see the other jobs. They can't see the unassigned tasks. They require the repair task update job status to job access and provide detailed information that the administrator later uses to create customer bills. Overall, the use case diagram helped me to clarify, identify the system boundaries and the required functionalities before I began any class design. Let's see them. Before designing the actual classes, I focused on applying the strong object-oriented principles. I make sure each class has single responsibility, meaning no class has more logic in it. I also used encapsulation by keeping fields private and exploring only the methods are needed. Let's see the class diagram. Now I will explain the class diagram. At the center of the design, the abstract user class defines common functionalities like sending messages, receiving notification from the base class. Have created three subclasses: customer, technicians, and administrator, and the keeps track of registration status, option to preferences, and the notification settings. Administrator has the methods like generating bills, allocating jobs, adding suppliers, and notifying the customer. And the technician have the repaired task related such as viewing jobs, recording repairs, and the job assessment. Then we have the equipment class. Here we have the brand, model, and serial number, and the repair job is very important class. In this repair class, we have the job ID, status, created, and assessed date and total cost, and this relationship with both the technician and the customer. And also I have created the supplier class to maintain the supply parts, which manages the supplier base class. Finally, the notification class, where we keep the notification ID, date, string, and we also keep the send two methods, send and receive. And also I want to explain about before going into the design patterns, I also want to explain about the polymorphism. One of the requirement was to demonstrate polymorphism that I used in several ways. Firstly, through the inheritance-based polymorphism, the abstract user class defines general behavior, but the subclasses override over the specialized methods. For example, even though all users can receive notification, the content and the behavior differs between customer and the administrator. Secondly, method overriding. For example, send message can be implemented differently depending on the user type. Thirdly, I used polymorphism with the collections in the place of list repair job. The system can store multiple different task objects and correct methods is called automatically at runtime depending on the actual task type. The use of polymorphism makes the design flexible and easy to extend. If the LMP technologies later want to add a new user, they can simply extend the user class without rewriting the entire design. Now let's talk about the design patterns. The first design pattern I used to talk is the factory method. Whenever a new repair job is created, the system does not directly initiate the repair job class at every part of the code. Instead, a dedicated factory method handles job creation automatically, generating the job ID and initializing the job status to a new job. And that makes the system more maintainable, because if LMP technologies want to change their how job IDs are generated, or if they want to add ignoring during the creation, they can update only the factory instead of entire code base. Now let's talk about the second pattern is the observe pattern. In this observe pattern, this observe pattern actually fits perfectly with the notification requirement. When a job is completed, the system to notify customers automatically. So the customer acts as the observer and the notification system acts as a subject. Whenever the job status changes to ready for collection, the subject notifies all the registered observers. This pattern keeps the notification mechanism flexible and it matches the real world behavior of the system very well. Without the observe pattern, the administrator would manually send messages, which is not scalable and reliable. Let's talk about the exception handling. Exception handling is the another requirement part of brief. I implemented built-in exception for input, output, and valid job IDs and empty fields that for CLI interaction. Customers exception handling using a class used no booking exception. This exception shows thrown a situation such as the administrator tried to view repair jobs but none exist. A new customer tries to view repair status without a job. This makes the system more user-friendly because instead of crashing the show errors, it provides a meaningful message explaining the problem. I also wrapped file operation, user outputs, and the menu interaction inside try-catch blocks to prevent the program from stopping unexpectedly. Let's talk about the design challenges I faced. The first challenges I faced is managing the relationship between the classes. For example, decoding whether the relationship should be aggregation or composition required carefully analyzed. Another difficulty was ensuring that the technician could see the jobs assigned to them. I had to design this carefully to avoid the security gaps. Next one is implementing the observe pattern was also sometimes hard because I wanted to make sure notification worked independently of their components. Lastly, keep the system clean, modular, and not mixing with too many responsibilities in one class was something I had to keep revisiting. Next, let's have a discussion of OOPS. This module helped me to strengthen my object-oriented programming. Before this project, I mainly thought about classes, objects at a basic level, but now I understood deeper concepts like designing principles, responsibilities, patterns, and the scalability. Working on the class designs and use case models taught me how important modeling is before writing any code. I also learned how inheritance and the polymorphism can simplify complex logic when applied correctly. Exception handling was the another area I grew in, and especially writing the custom exception instead of relying on built-in ones. The overall assignment helped me with the think more like a software engineer. Sorry. Now let's get to the conclusion. To conclude, I designed a completely object-oriented system LMP technology that support administrators, technicians, and the customers. I implemented core principles such as inheritance, polymorphism, and encapsulation, and I used the design patterns like factory observer to improve the structure and the scalability. Exception handling was integrated to make the system more robust. I addressed the real business requirements such as job allocations and the supply management and the notification delivery. Finally, this project has great learning experience, especially in understanding how to convert requirement into an actual system design. Thank you for watching my presentation.